So good afternoon to you once again. So now I am going to discuss about the electroslag welding process and the welding defects. So the electroslag welding is again another type of welding wherein electric current is used as a power source or the source of heat input, right? So what basically is electroslag welding, right? So electroslag welding is a non-traditional welding process, we can say. Okay, and in this welding, there's a molten metal pool which is created, and it is a combination of both resistance welding and arc welding, right? And the arc is established between the electrode and the base metal, similar to the arc welding process, and the heat leads to the metal flux and creates a molten pool between the electrode and the base metal, right? And the current flows from the electric or from the electrode to the through the molten pool. Okay, and the heat is generated due to the resistance or electrical resistance. Okay, and this electroslag welding process is a one process, or I means a process in which the welding can be done in a vertical position. Suppose, for example, we have two metals in such a manner, okay, that there is a gap here. Drawing is not that good. Okay, so for example, let us consider this is not there. So there is a gap here, right? So there's a gap, and you need to fill up this gap using the molten metal. So this portion has to be filled up, right? This portion. So in that case, what you need to do is you need to uh, have the perform the welding in a vertical direction. That is the, if I consider this as the electrode, okay, this is the electrode. So the electrode will be deposited layer wise, okay, and it will move up till the top. Okay, this is how the welding is performed. So it is also called uphill welding process. The uphill welding process is a process in which the weld joints are made in a vertical direction and the plates to be welded are held vertically. In normal cases, which we have seen, that the plates are in placed in a horizontal portion path, and this is how the welding is performed. But in this case, the plates are held vertically, and the gap between the plate is filled up using the welding process using the uh, metal. Okay, and again you make a think that when this is deposited it may spill out. So there is something called some kind of arrangement is there, okay, which makes sure from both the sides there is some arrangement which makes sure that there is no spillage, which is called shoe. Okay, we'll discuss about that, okay, in the following slides. Now the welding is done in both single pass and multi pass. I have already told you what single pass and multi pass is all about, right? So when it is when the welding is performed once, we call it a single pass welding, and in case in the same place, if number of times the welding is performed, we call it multi pass welding. Okay, so let us learn about the principle of the electroslag welding. Now, the electroslag welding uh, acts on the principle, or the heat generation is on the principle of arc, electric arc and electric resistance. Okay, so why once the arc is generated between the electrode and the base metal, okay, and it what happens, there is also filler metal. Okay, so there is a the filler metal starts melting up. The filler metal will fill the cavity at some extent. Now the current passes through the extended surface and the heat generated due to the electrical resistance. Okay, that is H equals to I square RT. This heat further tends to melt the filler metal, which is continuously fed from the roller. So filler wire is fed through the roller continuously. Again, in this case, we also have a roller where the filler wire is wound in the form of a spool. So this wire fed through the tube, which means what happens, this wire is directly fed into the means molten pool or welding zone. Okay, so this filler wire melts and fills the weld and we get a strong joint. So let us see the schematic diagram of this. So this is the power source. Okay, and here we have a control panel. So this is a wire reel. Okay, so there is some motor arrangements so that the wire can be pulled and pushed into this zone. So this is the green portion that we see are the two plates that are supposed to be joined. Okay, and there is an arrangement for oscillation of this welding torch. Okay, so torch, or we can say welding electrode guide. Okay, now there is a deposition of the metal, as we can see, in the form of a weld pool. And this is a shoe, as I was telling you. In both the sides we have this retaining shoe, and there is an inlet and outlet of water so as to cool the weld zone. Okay, and as the welding takes place, there's a slag which is formed on top of the molten metal. So that is called molten. That slag is in the form of molten form. Okay, so that is the reason why it is called the electroslag welding, right? So I believe this is very much clear to you that the wire passes through the slag, through the molten slag, and then due to resistance, electrical resistance and electric arc, heat is generated. Due to that heat, the wire melts and gets deposited in the molten pool, or maybe you can say between the gaps. And this keeps on moving up vertically, and we can also see this is a section which has been done to the shoe. So we can consider this shoe to, as in this entire portion of this will be covered, right, in both the sides. Okay, so that there is no spillage of that materials, as if you are trying to cover something from spilling. Okay, and in that gap you're just dropping the molten metal, right? Okay, now the working of the electroslag welding. So electroslag welding, as we have just studied, that it's an uphill welding process, so in which the vertical welding is performed at some distance. Okay, so the weld metal or the filler metal deposit between the cavities formed between the plates by melting the electrodes, and we can see that the heat is developed by the flow of current. So this filler metal forms the metal pool which solidifies into the weld cavity. So strong joint is created between the plates, right? So now what is the process in which the electroslag welding takes place? First is the current is flown, or the current flows between the electrode and the base plate or the metal to be welded, and there is an arc which is established between the electrode and the metal. Now this there is a heat of means we can say the flux which is there, okay, or the filler wire is which is there, that gets heated up, okay, and the filler metal melts and gets deposited into the weld cavity. Now the cooled copper shoe, the shoe which we have seen here, this is normally made up of copper, so that the uh, copper is a good conductor of electricity and as well as heat. So that is why copper is used here. And the copper also, as I told you, that there is an inlet and outlet of water through the copper shoe, so as to cool the cavity, or we can say the molten metal zone. Okay, so the cooled copper shoe comes into action, and the solidification of the filler metal starts, right? And also we can avoid the flowing out of the filler metal from the weld zone, as I already told you. So as the filler metal solidifies into the weld cavity, the current flow through it, and it will generate the heat due to the electrical resistance. This heat is further used to continuously melting down of the filler metal into the weld cavity. The filler metal continuously provide through roller arrangement as shown in the figure. So we have seen that there is a roller arrangement, this purple box, and through the roller arrangement, it is continuously provided or continuously passed into the welding zone. During welding, both copper shoe and the feed mechanism move upward until the whole cavity is formed. Okay, so we can consider that this entire portion will be covered, or this will move up in the upward direction, okay, as the welding is being performed, right? So this will create a strong joint in single pass. The single or multi-pass weld is used according to the plate thickness. So in case the plate thickness is higher, we can go for a multi-pass welding as well. Next is the application. Uh, so electroslag welding is applied in heavy industries where plate thickness up to 80 millimeter can be joined. So 80 millimeter, you can say you can consider understand that 8 centimeter thick plates can be easily joined using this process. And this process is used to join large castings and forgings. Suppose if you remember that we have used means we can use the permanent molds for casting. So in those cases, permanent mold, if they undergo any kind of fracture or breakage, we can join those molds using the electroslag welding, right? So very large structures or composite structures can easily be joined using this process. Welding of thick walled large diameter pipes, pressure vessels, storage tanks, ships can easily be manufactured using these processes. What is the advantage of this process? The cooling rate is very slow, okay. And why this water is passed on, the reason why the water is passed through the copper shoes, because the cooling, the amount of molten metal, you can understand that the heat is very high there. So definitely chances of creation of heat affected zone is there. So copper shoes have cooling tubes, so that the temperature of the heat or the solidification can be done, right? And the cooling rate still it is very low, okay, because the amount of molten metal that is there is much more in comparison to the other welding processes, okay. And since the cooling rate is very low, there is no possibility of cold cracking. There is no problem that happens. Cold cracking is again defect, okay, that is due to sudden cooling, there is a crack that can be generated due to uneven shrinkages or contractions. So there is again no problem of slag inclusion or porosity in electroslag welding. The process is semi-automatic and faster. So heavier sections can be welded in single pass, and high productivity can be achieved using this. And joint preparation, again, there is no requirement of joint preparation or edge preparation. Okay, because as we have seen that the gap can be easily filled up by the molten metal. You don't need to create any joint preparation or edge preparation for this process. Moving to the disadvantages of this process, too high heat input to the base, definitely, because the hot metal as well as the molten slag is means it's deposited straight away at the on the base material. Okay, so very high heat is there. Again, one more thing is very important. You can means you have this in your mind that suppose if I look from the side this process, so these are the two plates, and I am saying that there is an electrode which is moving down, right? So how the arc is generated, you may have this in your mind because there is nothing here, right? So what is the reason, or how the arc cannot be generated in air? You need to have something so that you can get the arc to be generated. So for that, what is done is there is some kind of arrangement which is made here. Some kind of plate is placed, or plate or tray you can say is placed here, and in that plate or tray some kind of, you can say, steel wool kind of thing is placed, and this arc is generated by the uh, between the electrode and this steel wool, right? And once the arc is generated, the material keeps on getting deposited in this manner. Okay, so due to arc and the electric resistance between the base metal and the electrode, the material keeps on getting deposited in this manner till the top. So, and this also moves in the upward direction, this electrode. Okay, so this is the reason, this is how the arc is generated, okay, using the steel wool. So too high heat input to the base, high temperature of welding needs cooling arrangement. We have already seen that cooling arrangement is provided in the copper shoes. Slow rate of cooling gives columnar grain in weld, right? So these are the things of electroslag welding, right? So electroslag welding, you can say it's again one form of arc welding process where the heat is generated due to the enormous amount of we can say the arc and the resistance between the electrode and the workpiece. Okay, so this was the end of this topic. I'll move on to the next topic, that is your welding defects. Okay, so if we are talking about welding defects, as we have already studied about the casting defects, so welding defects are again formed due to incorrect procedure. If you are not following the correct procedure, you may turn up getting some kind of defects, right? So we have to avoid these kind of defects. So let us see what are the defects before. Okay, so welding defects are the irregularities, or we can say imperfections, that are formed uh, due to incorrect procedure that we follow during our welding processes. Okay, so if we take certain precautions, if you follow the correct process, we can neglect or eliminate these kind of defects, right? So what are the types of defects we'll be discussing? So normally the what is a defect? Like the welding is a process by which two metals are joined. if the joint is not very strong and there is some uh, chances of failure in that joint, we can consider that as a defect. And also from the aesthetic point of view, if there is some the welding does not look good, in that case we can say there is a the welding is not proper. Again, we can perform some test on the welding and check whether the welding is sound or not. In case there is some defect, it will be proven that the welding is not sound and it may fail at certain duration during its what means in its application period. Okay, so the first defect is porosity. Now, porosity is a very common type of defect. In case there is, we have also seen that this porosity defect was formed in case of your casting process. Okay, so porosity, or we can say it is your blow holes. Okay, so these kind of defects are caused due to air bubbles or gases which are entrapped inside the or present inside the weld zone. Okay, so if there is a distribution of air bubbles in the weld zone, and if the distribution is random, okay, so what will happen? The porosity is caused due to the release of the gases during melting of the weld area. Okay, now if these gases gets entrapped inside the welding zone or weld pool, okay, during the solidification process, what happens, it reacts chemically with the welding, and or it may also due to some atmospheric contamination, some kind of reaction will take place, and it may result in some kind of defect. Now if we use proper electrode, proper filler material, improve the technique of the welding, and we provide, or we given more attention to the preparation of the welding, edge preparation. We allow some the gases to escape. We use a very slower speed. In these cases, we can eliminate this kind of defect. Okay. Now, this is how the porosity looks like. So as you can see, these are the porosities, and these may result in a later case that it may result in some failure of the material. Okay. Now, moving to the next part, that is, suppose we are using a welding current which is very high. Okay, as I already told you about spatter, that if in case welding current is very high, we can experience this kind of metal droplets which stick surrounding the surface of the surrounding the periphery of the welding zone, and this is known as spatter. And this can be minimized if you are using the correct welding conditions. Correct welding conditions means proper current, and definitely in case after the welding, if you want to remove it, because this spatter does not look good from the aesthetic point of view, so you can remove it by grinding. But again, you have to employ a new type of process wherein you have to also give some time. So it is better to eliminate this from its root cause. Okay, so the causes of this spatter is, if in case welding current is too high, the arc is too long, we use incorrect polarity. Incorrect polarity, again, if you are using reverse polarity, that is, if the electrode is connected to the positive end, what will happen, the more heat will be generated at the electrode end, and more means melting will take place at the electrode end, and rather than the deposition, the extra material will be thrown in the form of metal droplets. Okay, again, if the shielding gas is not proper, then also it may take place. So if you want to go for the remedies, you have to reduce the current and arc length. You have to use correct polarity. Okay, preferably straight polarity, and we have to increase the torch to plate angle and correct use of gas shielding. Right. Torch to plate angle. What is this? Torch to plate angle is, suppose this is your welding plate and this is the angle at which you are uh, performing the welding. This angle should be around 60 degree. So if it is reduced, that means suppose this is not 60 degree. In that case, what will happen? The welding is taking place and the arc is getting distributed in this manner. Okay, so rather than means the welding is performed here, however the metal pieces are getting deflected and it moves in front so that it becomes better. So this is again another factor or another remedial measure that you can take if you provide proper angle between the torch and the plate, that can also reduce the amount of spatter. Next is slag inclusion. Now, slag inclusion are compound of such as oxides, flux, and electrode content material. That is like in case of arc welding, manual metal arc welding, the electrode that you use is flux coated. So this is flux coated. The drawing is not that good. Please kindly bear with me. So this is flux coated. So when the welding is performed, this flux gets converted into slag. Okay. So that slag, if it is entrapped in the weld zone, in that case, what will happen? It gets converted into slag inclusions. So if you see this welding, so this welding has some slag inside the weld zone. Rather, normally we expect the slag to be deposited on top of the weld zone so that we can chip it off. Okay, so this defect is commonly associated with other defects like undercut. Undercut is like if we are performing a welding operation, so this kind of thing may be formed. Okay, so this is called undercut, right? So this thing may happen. Then we have the incomplete penetration. Incomplete penetration is again, suppose the entire material is not, entire portion is not getting filled up. We will discuss this. These are separate defects. This is the incomplete penetration, and again lack of fusion in the weld. So proper fusion is not taking place, which again results in incomplete penetration. Insufficient cleaning between the multipass. Suppose you are going for multipass welding, so you are performing one pass, again another pass, again another pass in case of submerged arc welding process, as we have discussed in the previous lecture. So in this case, what I told you is there is a layer of slag which is formed, so you need to chip that layer off before you deposit another layer. Okay, so if you're not doing that, in that case what will happen, and if you keep on depositing layer after layer of metal, in that case what will happen, the slag inclusion may take place. Okay, and like slag inclusion not only reduces the cross-sectional area of the strength of the joint, may also serve as a initiation point of the serious cracking, right? So we have to grind the entire welding or the portion where the slag is, and again perform the welding again, right? So in the meantime, I'm giving this lecture. I'll request you to enter your roll number in the chat box so that I can get your attendance. Please don't miss out on this. Okay, incomplete fusion. Incomplete fusion, again, as I told you, that if proper fusion or incomplete fusion or lack of fusion takes place, if there is like incorrect or heat, the heat input is very low, proper current and voltage is not being used, in those cases this may happen. Now the causes of this is low heat input, weld pool is too large and running ahead of arc, the joint included angle is very low, the electrode and the torch angle is incorrect, unfavorable bead position. These are reasons, and the remedial features of the incomplete fusion is you have to increase the welding current and decrease the travel speed, reduce deposition rate, increase joint included angle, position the electrode or the plate angle such a way so that the plate edges will melt, the position the bead in such a way that the sharp edges with the other bead or plate are avoided. Okay, so these are the remedial features of incomplete fusion. Incomplete penetration, I just told you that in case there is not proper penetration which is taking place, it may happen due to many reasons. It may happen due to improper joint preparation. In case you are preparing a joint in this manner, that is a square butt joint, okay, and you're trying to deposit some amount of molten metal here. So molten metal will be deposited here, however it will not penetrate the entire part. Again, you have to turn it, but it's not possible for all the, I mean, all situations that we can turn it on the other side and weld it. Okay, so we have to provide a proper edge preparation in order to go ahead with this. Again, it may be again a reason of the incomplete fusion or lack of fusion. Okay, so incomplete penetration is not proper penetration that is taking place throughout the thickness. Undercutting, okay, this is the undercut which I just told you. This is a defect where the base metal melts away from the weld zone, and consequent generation of a groove in the shape of sharp recess or notch is, and it also reduces the fatigue strength of the joint. So if the electrode which you are using is not correct, not proper material, incorrect electrode means not proper material. Normally electrode material is similar to the base materials. However, if you are not using the proper electrode, in that case may happen. If the electrode angle is not proper, if the arc voltage is too high and the arc is too long, the electrode is too large. Large means the diameter is larger. In that case, definitely more current is going to flow in the high electrode speeds. If the speed is higher, in those cases also this may happen. So all these causes, if you just don't follow these causes, and you have to, like, just the opposite of this, lower the arc voltage, use smaller diameter electrode, reduce travel speed, and apply electrode angle 30° to 45° with the standing leg. In that case, with the standing leg is there in this is the case. So you can go for a or you can get a weld undercut free welding. Underfilling is something like this: if the weld is not filled up properly. Okay, if the means proper filling is not done with the proper amount of molten metal. Okay, so again some extra material has to be deposited, or you have to use some filler material in order to prevent this kind of defect. Inclusion means again some material which gets entrapped into the weld zone. So it's a defect with several passes, are made along the V joint when joining thick plate using flux core or flux coated rods, and slag covering the run is not totally removed every pass before the following pass. So it is in slag inclusion or flux inclusion. You can also consider lamellar tears. There is mainly a problem with low quality steel. It occurs once like this, if the plate has very low ductility. Okay, and normally inclusions like sulfides, oxides that have been elongated during the rolling process. Lamellar tearing can occur in both fillet and butt welds, but most affected joints are T and corner joints. So in case of T joints and corner joints, this kind of defects may arise. These are the T joints or corner joints, you can say, right? Next is your cracks. Cracks may occur in various location and direction in the weld area. The typical type of cracks are longitudinal, transverse, crater, underbead, and toe cracks. When joint is at elevated temperature, then the crack occurs and it's known as hot crack. Okay, so causes is it's due to the welding ended far too abruptly. The crack begins at the void in the welding crater caused by the solidification shrinkage. So remedy is when finishing, move back the electrode to fill up the crack. So if there is a crack generated, you just move back, okay, go back and fill up the crack using the electrode. Okay, deposit the material there. With root pass welding, quickly move the arc from the welding pool to the plate edge. Okay, increase crater fill time by power source. Arc blow is another defect. It's undesirable effect. It is called magnetic or thermal arc blow. Normally, it is due to the magnetic effect. Okay. So the causes of the arc blow is the arc deflection as a result of magnetic effects in the direction of the heavy part of the workpiece, especially at corner and edges. Arc deflection as a result of magnetic effects into the opposite direction. Like suppose this is an arc blow here, as you can see in the diagram. So accumulation of the bead is on the other side. Okay, so this is a effect. So this part becomes weaker. So remedial action is you have to use a AC electrode wherever possible and keep arc as short as possible. Try welding away from the arc clamp connection and try splitting the arc clamp and correct to both sides of the joint. So there are two types of weld testing: destructive testing and non-destructive testing. Destructive testing means you perform the test by destroying the material. So in case there is a huge quantity of material that you have welded, similar kind of weld, one part you can destroy and you can check. Okay. However, for non-destructive testing, we have followed NDT like X. We can go for penetrant testing, dye penetrant testing, magnetic flux testing, and other X-ray, gamma ray, ultrasonography, different kind of testings are there. So thank you very much for attending this session. Okay, in case if you have any doubt, you can get back to me through WhatsApp. Thank you very much. So I'll end the meeting here.